Hey everyone, the student asked me to look into this significant figures problem that shows up in RealChem, even though it's from a future week. I know it's a little confusing when some of these things can be due. Let me take a look here. We go to preview as a student, and I think schedule. It was right here. So significant figures is a way to, it's like the most primitive way to do error analysis, right? We're just limiting ourselves to reporting as many non-zero numbers as we read in the problems. And there's different rules for summing and adding and subtracting, and for multiplying and dividing for products and dividends and things like that. So there are a series of rules. So look at it. I'm not going to go through this and make this into a lecture, but let's just look at one of these problems. So we have two problems here. We have our two numbers. We have 6.3341, which includes 1, 2, 3, 4, 5 significant figures. And we have another one, 2.110, which has 1, 2, 3, 4 significant figures. So a 0 to the right of an integer, to the right of a decimal point, is significant. 0 to the left of an integer, to the left of its decimal point, is insignificant. But in this case, we have 4 on one, and we have 5 on the other. And had I my Apple Pencil, I could have done a better job of highlighting the screen while I record this. You might be unable to do that right now. But let's go ahead and look at my handy, trusty calculator here. If I can do that, if I can get this off the screen. So I'll use my handy phone emulator here. This is an emulation of my physical own calculator. It's my HP 48 I've had since 1989, the best calculator ever made. And so what I did was I went to units here. This is unnecessary, but for the sake of being thorough, length, and there's meters there. So I'm going to enter 6.331 or 6.3341 meters, and then I'm going to enter 2.110. Now notice this thing doesn't know about this 0 being significant or not, so it won't record it. It didn't. If I wanted it to force it to record it, I would write this in scientific notation. I'm going to multiply them. I'll take the object in the first and the second positions of the stack, multiply, and you get 13.364951 meters squared. So I'm going to go ahead and write that 364. That's all I need, because I only need 4 places, so I only need 13.36 meters squared. And I don't know what happened to that thing. There it is. Let's scooch it off to the side here, and we go submit. We'll see if we got it right or wrong. And what do you know? We got it right. So it's rounded to the term with the fewest number of significant figures, and it says, hey, 6.3341 has how many? And they're all integers, so every integer is always significant. So we're only worried about the zeros. 2.110 has, this is the tricky one, because there's a 0 at the end, but you don't write a 0 at the end of something unless it is significant. So it's going to be 4. How many significant figures should the final answer be rounded to? And the answer is 4, because it's the term with the fewest significant figures for the multiplication operation. That wouldn't be true for addition or subtraction. And what do you know? We got it right. This one's a little different because it reads, perform the following calculation and round your answer to the correct number of significant figures. Choose the correct unit for the answer. And the calculator has stopped cooperating there, but so we have 6 liters and 2.7552 liters and 4.03 liters. A little different. This case, we'll go ahead and go through this addition operation, and we'll even put the liters in. I just want to show you what the calculator does, which is interesting, how it knows. We put 6.00, which is, in this case, it's 3 significant figures, 0.00. And I'm going to go back to units and volume and, whoops, next page, liters. Again, it got rid of those trailing zeros. I could have forced them to stay, but I didn't. we have 20, very much more. They're clearly using a different measuring device for this one. 2 liters. I'm not even sure what that would look like. And we have 4.03 liters. Now, you might remember that we last time looked at the term with the fewest number of significant figures. In this case, these two are tied for 3. But in this case, we're looking at the term with the fewest number of decimal places. This has 3 significant figures. This has 6, and this has 3. But we want the term with the fewest decimal places because this operand is an addition operation. So I'm going to go ahead and add these, and look at this. It doesn't square or cube these. We get 30.7852 here, but we want only 2 decimal places. So we're going to go with 30.79. We'll round that up. Strictly, we should round this to an even number. It should be 5 splits the difference to even. So we'll see how it behaves, how it likes me to do this. 30.79. Usually in an introductory course they'll let you just round up because that's what they teach you in other schools. But we don't square or cube this because we're adding, we're not multiplying. And we click, yep, there we go. And let's see this last one here. Here's another one. Perform the following operation and round your answer to the correct number of significant figures. Choose the correct unit for the answer. So in this case, we do everything. We do the order of operations, which is everything in parentheses first. Then we do multiplication and division. And if anything's tied, we go left to right. So let's have a look gander at this and see what we get. We get the calculator back if we can. So we're going to start inside these parentheses with 25.3 centimeters. That's just about an inch. So we're going to go back to units. Come here, you stinker. Units, and why is it not going to units? Go to units. There we go. Length, centimeters. And actually, I'm going to go ahead and I'll take that off. I'll put in the 2 centimeters first. 2.0 centimeters, and then I'm going to put in. I'll enter 25.3. This thing is not taking my clicks very well. 25.3 centimeters. And you know, division and subtraction, the order of operations makes a difference. It does not make a difference for multiplication and addition. So it depends, because these are a left to right operation, and division can be left to right, but you can multiply either direction. It doesn't make any difference. But then we have 1.6850 centimeters. Now we're going to subtract, but then we have to keep our sig figs straight, because if you remember, we only keep the number of decimal places at the term with the fewest decimal places, which is just 1 in this case. So we're going to subtract out this. Remember, it's just that, but we only get 23.615, right? We can only use that moving forward. So I'm going to go ahead and write 23.615. I'm just going to keep it clean, because sorry, we only get 23.6 because we only had 25.3, which is 1 decimal place. Centimeters. I'm going to go ahead and enter that. I'm going to swap. Whoops, I entered it twice. I'm going to swap these last 2. I'm going to drop the 615 off. Now I have these 2 to multiply, and I get 47.2 centimeters squared, but I only get 2 total decimal places, so I get 47 centimeters squared, because I only get 2 because this only has 2. So I have 47 now centimeters squared, and I submit, and let's see if the magic happens, and we got it right. What do you know? We're doing all right. And so the others are just like this. You can continue and do similar things. Maybe I can show you if you'd like. Perform the following calculation around your answer to the correct number of significant figures. And in this case, we would get meters per second, but we would do the subtraction operation first, and then we would divide by the 2.8. Maybe we can just do it real fast. If you want to see, we can say, I won't do the meters and stuff. 17.41 1, enter, 3.8925, whoops, I need to put a point in here, and then we'll go enter. Now we subtract. How many places do we get? We get the one with the fewest, so we get 13.52. So I'm going to go ahead and just write 13.52. You don't have to do this. If you did the math, it would still come out okay. I'm just doing it for the sake of exposition. Then we take 2.8 divided by. Now we're doing a divisor operation. So we keep two significant figures in the answer. We go divided by, and it's only going to be 4.8. So we get 4.8 meters per second. Will be the answer. And we submit, and what do you know? We got it right again. All right, so let's look at this one here. We have three terms that are written in scientific notation. Both the abscissa or the decimal part is here, and then we have times 10 to the some value. It would be an engineering notation if these were all multiples of 3, but they're not, and so the scientific notation. This 0 is significant because it's in scientific notation. Any number in the decimal part is significant in scientific notation. These numbers are always between 1 and 10, and this is always a 10 to the some power. So this has two significant figures. This has 4, this has 3. This is a multiplication operation, so we report the answer as the same number of significant figures as the term with the fewest significant figures, which is 3. And let's just pop it up here. Let's go with, we've got millimeters. Oops, let's go with 3.0. And in this calculator, you click EEX. Sometimes it's EE, sometimes it's just E, sometimes it says like 10 to the with a little caret up arrow. So this one's EEX, and then we put 6. And I'm going to click millimeters, and enters it. Then we go 8.293 EEX. This is going to be a big number because we're now multiplying 1,000,000 times 100. Then we want 1,000,000 times 100 times 50,000. So let's go 5.05 times 10 to the 4th. This is going to be a big one, Okay, so we're going to multiply this, and we should get millimeters cubed when we're done. We do with 1.2, round this up to 6, because we get, or sorry, 1.3, because we get only two significant figures, so we 1.3 millimeters cubed. So we write the 1.3 times 10 to the, what was it again, 14? Yeah, 1.3 E, and we would write that with E to the 14. I think it doesn't matter if you use large or small. Either 14 millimeters cubed, and we see if we got that one right. Lo and behold, we did. And then significant figures here is 2, and here it is 4, and here it's 3, and the answer is going to have 2, and that's it. Let's see if there's anything else that's particularly tricky. I don't think it is. I think you're getting it by now. Perform the following calculation around your answer to correct number of significant figures. This is just multi-steps, so it's multi-units. So I think we can handle it. What do you say? Let's give it a shot. This one is, now remember, this is an addition action, so we keep the answer has the same number of decimal places as the term with the fewest decimal places. So let's type 5.3940. Oops, I forgot to put a point in there. Point, I guess we should go to units, mass, kgs, and then we'll put 3 point. Now, order of operations, again, on an addition or subtraction does not make a difference. We could have gone either order, but it does make a difference for subtraction. So we're going to add these and keep just 2 decimal places. So I'm going to go ahead and rewrite this as 8.394 kilograms. Whoops, wrong button. Kilograms. I just did it again. 8.39, sorry. It's late. I in Scotland and I'm jet lagged. Let's see, 8.39 kilograms, and then we're going to write we're going to divide that by 3.5 times 10 to the minus 2. And this might be a little bit interesting. With 3.5 EEX, the exponent key, instead of using minus, we don't use the subtract key. There is a plus e minus e key here, a parity changing key, they call it. You can either go to minus or minus 2. I'm going to go to minus. Here, enter. And then I'm going to divide one by the other. Now I keep between these two, it's the term with the fewest number of significant figures. They both have 3, so there's 3 in each. We'll subtract, and the answer is 240 kilograms because we round this up. We can write it as, I wonder if we can write this with scientific notation. Let's try it. I don't know the answer. Let's try 2.50 e to the second power, and let's go kilograms per meter cubed. It's the density here, and let's see if it works. I don't even know, actually. What do you know? It knows the difference. So that, my friends, is how you do those exercises on, I guess we did all of them, so yay for us. We did all of those problems with significant figures. Excuse me. I hope that helps. Take care. See you later. Bye-bye.